We're looking at the same attributes for this graph. So the first attribute we're looking at is when is this graph positive? Positive is above the x-axis. So we read the graphs from left to right. The graph is positive over here, and it looks like it's coming down, but it also looks like there's an asymptote at x equals 0, so it'll never actually touch it. So it will stay above and it'll stay positive. So I'm going to say this graph is positive from negative infinity, stays up, all the way to this asymptote here, which is at x equals -2. Now the graph is positive after the asymptote because it's above, all the way to x equals 1. So I'm going to say from negative infinity to -2, and then from -2 to 1. Now I can't include -2 in either one of these because it's an asymptote and the graph will get closer but not touch. I can't include x equals 1 because the graph actually touches the x-axis, which is 0, y equals 0 at x equals 1. 0 is not a positive number. The graph becomes negative right here, so from 1 to 2, not including 1 nor 2, the graph is negative. So from 1 to 2, it's below the x-axis. And we have another asymptote at 2. If we look, the graph is above after x equals 2 and will stay above because we have a horizontal asymptote at y equals 0 right here. So I will say from 2 to infinity, the graph is positive. So we have 1, 2, 3 intervals where the graph is positive, 1 where it's negative. When is the graph increasing? Remember, from left to right, when are the y values going up? So from negative infinity to -2, the y values are going up, the graph is increasing. We have to stop and start over at -2 because we have an asymptote, and you can see the graph is decreasing, decreasing. It flattens out here, but it's actually just decreasing very slowly through that. So it's decreasing from -2 all the way to 2, not including either one of these values because of the asymptotes. So -2 to 2. After 2, you can see that the graph is decreasing again. It starts up really, really high towards positive infinity and comes down. So I'm going to say we are decreasing on 2 to infinity. Now concave up, bowl shape up. So if you look at this first piece of the graph, it is bowl shape up. So I'm going to say from negative infinity to -2. This piece of the graph, it's also bowl shape up right here. So from -2 to 0. At 0, you can see bowl shape up, and then it switches bowl shape down. This is a point of inflection where you change concavity, so I'm going to say x equals 0. And it's a special kind. Some people call them a saddle point. They're the easy kinds of points of inflection to actually spot. So from 0 to 2, it's bowl shape down. Then we look to the right of this asymptote, and we're back to bowl shape up. So concave up from 2 to infinity. For cusps, we're looking for sharp turns on the graphs, and everything here is nice and smooth, so we have no cusps. The next attributes we're going to look for are extrema: relative maxes, relative mins, absolute maxes, absolute mins. So a relative max, remember, is a high point in an area. It has to have graph existing on both sides of the point. A relative min, a low point in an area. So if you're going along and looking at these, we have no relative maxes and mins, and that's okay. The graph doesn't have to have any. So we have none and none. Okay, an absolute max is just quite simply the highest point on the graph. And if you look at these graphs, they go up forever. So we don't have a highest point. Absolute min, the lowest point on a graph. If you look at this piece right here, It's going down forever. There is no absolute min. For continuity, intervals where it's continuous, we're going with a very informal definition, so where can you draw this without picking up your pen, going from left to right? So way out here to the left is negative infinity. I can draw it, but I have to pick up my pen right here at this asymptote. So I'm going to say from negative infinity to negative 2. It does not touch negative 2, so that gets a parenthesis. Put the pen back down from negative 2 to 2. Remember, we're listing x values, so from left to right, negative 2 to 2, this graph exists, and I don't have to pick up my pen to draw it. So from negative 2 to 2 gets included. I pick up my pen because of the asymptote. I'll put it back down right on the other side of the asymptote. So from 2, and then this graph goes to the right forever. So from 2 to infinity, it is continuous. So there are 3 intervals in which this graph is continuous: negative infinity to negative 2, negative 2 to 2, and 2 to infinity.